So my name is Murat. I'm co-founder and CEO of Megamind Academy. I'm also a Stanford scientist. I do biotech and I did particle physics. I've been working with data for the last 20 years. And we've been providing a lot of free lectures, workshops for as a Megamind Academy and boot camps. And if you guys have attended these programs, I hope you all benefit from it. And if you benefit from it, if you just believe it is really good and we want to keep providing that, I will appreciate if you leave feedback on several different platforms. It could be Yelp, Google, and our friends can share these links for the platforms for our company. And we hosted over 120 events almost last 1.5 years, and we double our events in the COVID. And we even start to give free mini boot camps and workshops. And I'm actually reading the chat, and I can see really so diverse Python experience. And we will send you actually a detailed feedback form. I will appreciate if you fill it. It will really help us to organize the future programs. And also it will help us to schedule new programs so you can also benefit. So again, we have meetup groups. We are in 4 or 5 different locations, and if you are not in one of these meetup groups, I recommend to join them. This is the actual first place we announce our events. And if you are not in our mailing list, then you can go our website and join our mailing list. And we are also launching we are broadcasting our events in YouTube and Facebook channels. And you can also subscribe those places and like YouTube and Facebook page. So I would recommend to get engaged in several different platforms. We try to advertise our events in different locations, but there may be a chance that we may miss some, so you don't want to left out. And this, I hope you guys have enjoyed this program, and we're gonna keep launching new boot camps and workshops. So I like to announce our new program. And we actually finished the deadline for mentorship bootcamp last week, and we starting batches this week. And for the new program, I like to announce that we are announcing a free, sorry, not free, full stack data science bootcamp. And I will actually share the link, and I will say how this full stack data science link is, bootcamp is. Okay, let me see. I hope you guys see the screen. Okay. Do you guys see the screen? Okay, great, thank you. So the goal with the full stack bootcamp. So in 14 weeks, we would like to give you all the required aspects or necessary aspects of data science. So you can be comfortable with working on projects. And we have like it is in 3 different steps. One is the basics. We teach Python, and it will be more advanced than what you learned today. I mean, this program. And it will be SQL and it will be stat math. And also in the next one will be machine learning, NLP, big data, cloud we are teaching. And there will be in 3 different lecture sessions in each program. And we have also project and career sessions. So in the last 4 weeks, you are going to work on the project with our mentors. The first one is more lecture style with the small class sizes, and the projects will be with the mentors. So this one, if you don't feel comfortable working in projects, and if you need more knowledge and more background, I will highly encourage to join that program. What is difference within this program and mentorship bootcamp? Mentorship bootcamp is more advanced level, and the projects is more real life projects, and we really can't accept everyone. We have a fourth of acceptance rates in there, but because of the need in there and demand in there, we decided to add full stack program. So the full stack program, if you don't feel comfortable with data science, if you learn from different places, but still like a lot of loops and gaps to perform the projects, I highly recommend that. So we are actually gonna start to get applications next week, and I highly recommend to get in the mailing list. And you can just send me an email if you have any questions on it. So my email is, so actually I have a problem with my email. Just send me muratbadai@gmail.com. There's a problem with the company email, so you shouldn't miss that. And yeah, if you have any questions, send us an email and happy to answer. I hope you guys benefit from this session, and please give us feedback to me and Dr. Karasan. Hope you enjoyed the last class.
Thank you for the introduction, Dr. Murat. So this is our last session. This is the fifth and last session. And in this session, we are going to talk about correlation and regression and some important APIs for extracting the data from online. So let's get started. I will share my screen, and from time to time, I will go back and check your questions. All right. So before coming here, before starting the session, we sent an email to you about the data set that we are going to use during our session today. This is one of them. We are going to use two different data, and this one, the movie data, is one of them. And to save some time, I import the libraries and prepare the movie data. All right. So this we are going to use this movie data to figure out the correlation between the variables. Okay. So let's observe the data first. So this data is about movie. How much money you make from the movie, or what are the ratings of actor 1, actor 2, whatever they are, and the duration of the movie, number of critics for review, director name, and etc. Okay, these are information about the movie, and you can answer various questions using this data. Okay, but for the sake of this session, as I said, I'm just going to run the correlation. But before doing that, let's observe the correlation using visualization technique. I will use scatter plot. Movie data has a column named number of critics for reviews. This variable will be my x-axis, and the gross variable will be my y-axis. Okay, gross means gross revenues generated from the movie, the related movie. Okay, this is my x-axis, this is my y-axis, and what else? Let's give a title to it, like number of critics, and gross revenue. This is my title. In order to be precise, I would like to assign X and Y labels. X labels is number of critics. Y label is, hold on a second. Y label is this one, gross revenue. Okay. All right, so, and then PLT show to get rid of the text underneath the graph. So let's run this. So this is what I have. This graph tells us that there is a correlation between the gross revenue and number of critics, but I don't know the correlation coefficient. I have no idea about the magnitude of the correlation coefficient. How strong is this correlation? I have no idea about that. Okay. But what I understand from this visualization is that there is a positive correlation between number of critics and gross revenue. Okay. In order to figure out, in order to determine the correlation coefficient, we use movie, the name of the data, and core. If you are going to use the correlation coefficient in Pandas, this is how we do it. So by doing this, we have correlation coefficient, which gives us the exact information about the correlation, about the relationship between the variables in the between the variables of the numerical data set. Please pay attention. If you have an object variable in your data set, they are automatically dropped. What we left off are the numerical variables only. Okay. So before diving deep, I would like to briefly talk about the correlation coefficient. This is an informative statistics that measure the correlation of two continuous variables. These are the continuous variables. And the correlation coefficient is a numerical representation of the linear relationship between two continuous variables. It ranges from -1 to 1. If it gets the value of 1, it means that there's a one-to-one relationship between the variables. If it is, and it's positive. If it gets -1, there is a negatively one-to-one relationship, inverse relationship. In between, we have somewhat relationship, but it depends. It depends on the correlation coefficient. All right, if you pay attention to the diagonals of this matrix, it's a huge matrix because we have tons of variables. If you pay attention to the diagonals, we have ones because these two variables has one-to-one relationship because they are identical. They are same variable. So that's why we have correlation coefficient of 1. If we look at this one, the correlation coefficient between duration and number of critics for reviews, it's 0.25, which means that there is a positive relationship between these two variables, but it's not that strong. How about, let me find another one. I don't want to talk about this and other stuff. How about this? Number of voted users, number of critics for review. The correlation coefficient is 0.62, which can be considered as high correlation. So this one, number of voters user, number voted user, has a positive correlation with number of critics for reviews, but it doesn't tell us that. It doesn't tell us the causality between the variables. It just tells us the correlation between these variables. I mean, I have no idea about the direction of the correlation, direction of the causation, okay? Simply looking at this correlation coefficient, I cannot say that number of voted user, an increase in number of voted user leads to an increase in number of critics for reviews. I cannot say that, or other way around. Okay, this is another topic. The correlation coefficient just gives an idea about the relationship between two variables. Okay, this is how we run the correlation coefficient using the Pandas function core, as you see here. How about using Seaborn? In order to do that, I assign a variable first. I create a variable first, which I assign an arbitrary name movie math YouTube, movie core. I assign all the correlation inside of it. Okay. Then I will use seaborn package, and heat map gives a fancy way to observe the correlation coefficient between the variables, between the continuous variables in the dataset. Math YouTube. Okay. Movie math YouTube. If I do that, hold on, I need to add some. Okay, anyway, let's do it. This is what I get. Okay. So we have a color bar on the right hand side. Okay, we have tons of different variables here. So this color bar tells us the strength of the correlation coefficient. If it is light color, there's a high correlation between the variables, as you see on the diagonals. They are nothing but ones. But if you check this gross and vinsorized gross, the correlation coefficient is quite high. And for instance, if you check this out, actor one Facebook likes, cast total Facebook likes, the correlation coefficient is again high. But it's really hard to interpret. So why we play with this? I'm going to add some annotation to see the correlation coefficient on the screen, and I will play with the digits by doing this, 2 floats, 2 decimals. Okay, then I will add the size of the correlation coefficient, which is I define as 6. Okay, what else we got? I can play with the line widths. I prefer to choose 0.5. Vmin and Vmax defines the minimum point and maximum point of the color bar here. It starts from minus 0.2 ends at 1, but now I would like to start from 0 and stop at 1. Okay. What else? The type of color map, which is this, and that's fine, I guess. Let's run this. Oh, I get an error about the line widths. There's a typo there. Okay, line widths. This one, I guess, right? Line widths. Okay, here we go. Let's, we can make it bigger, but let me do it this way. Save some time. So this graph gives us, this heat map gives us the exact correlation coefficient between the variables, and it does that in a nice and clean way. You see, I play with the color bar, I play with the line weights, the decimal points and the size of the points inside the heat map. Okay, this is really fancy way to have the fancy way to analyze the correlation coefficient. Do you have any question? By the way, I'm lost on SNL plot in beginning. What we are doing? Could you please repeat that? Sorry. Okay, Farida, I'm repeating for you. So what we are doing here is check the correlation coefficient between the variables. Basically, we are doing the same thing in here, but here we use Pandas package, Pandas core library, but here we use seaborn package to do that, seaborn heat map. So if you are going to make a presentation, so heat map works better than, simply core. But if you are running some, scientific research, core is fine too. The core function is fine too here. So it's all up to you to decide which one to use. It depends on the purpose you have. All right, it seems like you don't have any other questions. If you have, feel free to type it in the Q&A. From time to time, I will go back and check them. Okay, the other topic I would like to discuss today is the financial or, and economic data sources and APIs, related to APIs, okay? So normally you need to go to the website, find the data set, download it in a proper format, CSV, Excel, JSON, HTML, whatever they are, store it into your local computer, call it from the proper directory into your Jupyter notebook and run it, okay? This is what you do normally. But now I'm gonna tell you the very convenient tool to call this data, okay? By the way, you have some questions, I guess. Rajeshwari has a question about heat map. Can you please explain more? Okay. Heat map is the same thing with the Pandas core function again. These numbers right here gives us the correlation between the specific variables, okay? For instance, actor 3 Facebook likes, the correlation coefficient between actor 3 Facebook likes and number of critics for reviews is 0.27, which means that there is a positive but somewhat low relationship between these two variables, okay? If you have a negative correlation coefficient, which means that there is a negative relationship between the related variables. This is how it works, okay? And if you check the diagonals again, these are nothing but ones because these are the correlation coefficient of the same variables. Number of critics for reviews, number of critics for reviews, duration. That's why we need to focus on the off diagonals, okay? A question from Dave, what is the easiest way to sort the correlation coefficient and print them from highest to lowest instead of using heat map? Okay, if you are going to do that, this function works well because it's in a data frame format. You can play with this. You can sort values using the movie core. You can do that. We are going to discuss linear regression towards the end of this session. Here in the linear regression, we have an assumption called multicollinearity, implying that we cannot use two variables at the same time in our regression if they have high correlation, okay? So it's a good question, Dave. In this situation, if we have multicollinearity between the data, between the two variables, we need to drop either one of them, okay? In order to do that, we need to list the correlation coefficient in an ascending or descending order. We need to do that, okay? Because as a rule of thumb, if we have correlation coefficient of greater than 0.80 between two variables, it implies a multicollinearity, okay? So that's why we need to focus on the correlation coefficient greater than 0.80 and drop either of the variables, okay? So long story short, you can use this function. If you play with this, you will see how we select and filter the coefficient, correlation coefficient, okay? All right, let me go back to the APIs. We talk about the long way to save, store, and call the data. And the short way is this. For those who has no idea about the APIs, you need to use PIP to call it first, okay? Once you do that, you don't need to run the PIP again, but let me let me introduce the topic first. I will use Yahoo Finance. Okay, Yahoo Finance API. Okay. If you are a first-time user, please type this. If you are using Jupyter Notebook, do not forget to put a exclamation mark before PIP or PIP3, depending on the version of the Python you have. Exclamation sign, PIP install yfinance. Yfinance is the name of the library, name of the API that we are going to use. All right. So if I run this, this is what I get because I already used this package, requirement already satisfied. Okay. Now what I need to do is to call the library, import yfinance as yf. So I abbreviated as yf, the name of the packages, Yahoo Finance. All right. So what else we got? Let's start, importing some, start extracting some data from Yahoo Finance. It's really easy to do that. All you need is to know the ticker of the stock. Ticker is the short name of the stock. Okay. Here, AAPL is the short name, is the ticker of Apple. MSFT is the ticker of Microsoft. You can find the tickers simply by Googling the stock. If you Google Apple and type ticker next to it, you will see that the ticker will be, you will see that the Google gives you the answer that this is AAPL. It's really easy to find. All right, so I need to define when I'm going to start my analysis. To do that, I use this function, datetime. I just specify a date. You can specify your own date, your own start date and end date. End date will be, let's do it. Okay. But before using this datetime, I need to import the datetime function to datetime library too. Okay. So Yahoo Finance and datetime is enough to extract the data. Stocks is the name of my variable. I will store all the variables, all the data into this variables. yf.download stock coming from here, this stock coming from here. Start is start coming from here. Start is in the function. You can type your date here like this, or you can do like I do. Sorry. You can type this, or you can simply type start because I define it here. And I need to define the end dates, which I did here. And what is left is interval. You can extract monthly data, daily data, yearly data. I prefer to extract daily data. Let me run this and this one. If you see this, 3 of 3 downloaded, it's up and running. So what's left is to call it stocks.head. Here we go. So we have more than one price, as you see, adjusted close price, high price during a day, low price during a day, open price, and volume. So let's select one of them, one of the column, to move forward and see what it looks like. Stocks.close. If I do that, I select the closing price of Apple, Intel, and Microsoft. You see, starting from 2010. So let me tell you one more stuff. So I defined the day here, but this is not a business day. This is the first day of the year. So there is no business in here. That's why they go back 1 day back and take this day. Okay. Do not confuse with that. This is my starting date. This is my end date. So you can do anything you like with this data set. It's all it's ready. Okay. It's really nice and convenient tool considering the alternative way to extract the data. You need to go to the website, find the proper data, download it into your local computer, etc. This is time-consuming step. But if you use the APIs, this is really easy to call the data. Okay, this is one of them. How about Fred database? Okay, Fred database is a comprehensive one, and it's for free, by the way. All you need to do is to access the dataset using the APIs, and differently you need to have your own API key. We don't have any API key in Yahoo Finance, but it's required to have an API key in Fred. Okay. So again, before starting, if you didn't install Fred API, you need to run this code if you're a first-time user. Once you do that, all you need to do is to call the library. From Fred API, import Fred. Okay. Then I store my data in here, Fred API key. I have my API key. Let me find it. Let me find it somewhere here. Where's my API key? Should be okay. I have this. This is my API key. I can send it to you in the chat so that you can use it too. All right. This is my API key. Feel free to use it to run this, Fred API. Okay. So let's run this. Okay, it works. So what's left is to call the variables. Now, in order to call the variables, as I said, it's a comprehensive data set. There are lots of different variables in here. So I'm going to use a keyword to find my variable of interest. So let's say interest. If I do it, it's just a keyword, by the way. What I have here is the variables with a word interest in it. Okay. All right. So here, what I have, effective federal funds rate, effective, the same thing with the different frequency. 10-year treasury constant maturity rates, and etc. You see, there are different types of interest rates. So it is 965 rows. So it's huge. All right. What I need to do is to define my variable. So let's use this. So I need to specify series ID to call the data. Please pay attention here. Once I decide which variable fits my purpose, then I need to go to the series ID and copy this and paste inside this code. Fred.get_series inside the code fed funds and assign a name and a variable name, interest. Okay, that's great. Let's observe the interest. Here you have the data. Boom, that's great. So you see, starting from 1954, ends at 2020, you have the federal funds rate. So feel free to visualize it. It's really easy. Interest, PLT title, let's put the title here. Monthly interest, it's a month interest rate. Okay, PLT X label is percentage. It's a percentage because it's a rate. PLTY label is date. PLT show. Let's see what it looks like. All right. So the monthly interest federal funds rate goes up all the way up until 1980 and goes down with the same pace to until 2020, 2010, and then there is a stable path here. Then it goes up, and starting from I guess mid 2019, it's declines. It declines, and this declining period persists. I guess continues. All right. So this is how we extract data using Fred API. Let me see if you have any question. All right, I couldn't find the key. I sent it in the chat, Ferda. Please let me know if you don't have. It didn't appear in the chat. Okay, let me do it. Let me do it once again. The Fred API. And let me know if it doesn't work again. This is my API key. You need to use it inside the code. Please remember this. And we need another API key. Let me provide it to you before running the analysis. This is the API key for the next API. Okay. And it doesn't show up in the chat or Q&A. All right. What's the problem here? Let me try Q&A. Maybe you have but I cannot send the answer to all of them. Okay, let's do that. Do we have the API key now? I send it to you further. Yes, I'm sorry. Maybe I didn't send it to the attendees, but yeah, I'm sending to all panelists and attendees. Okay, how about this? You have the API now? Okay, sorry about that. I missed this point. So for the quantile data set, we need another token, which is called token in the quantile case. This is it. We are going to use it right now. Okay, we are all set. Okay, let me share my screen again and go back to the class. You don't have any question, I guess. Okay. Great. We talk about Yahoo Finance, Fred, and now it's time to talk about Quandile. Quandile dataset, Quandile API. So again, the first step is to use PIP to install the Quandile like this. Okay, for the first time user again. If it is running, now you can import the Quandile like this. Let me run this. Import Quandile. That's easy as it sounds. So so I'm going to import the oil price using Quandile. That's why I use oil as a name of my variable. Quandile.get. This I don't want to go too much detail, but if you visit the Quandile website, you will see some, shorthand notation for the variables. This is one of them. If you are going to import the oil price from the International Energy Administration, this abbreviation is the one you need to use, okay? And again, you need to have the author token. This is the same thing with the key in Fret database. Let me check if there is any typo here. Author token, no, there is not. Okay, sorry. So this is the author token that I have. You can use it. And what is left is to define the start and end date. Start date is, in my case, 2020 01 January 1st, and end date is 2020 January 1st again. Let me run this. Okay, I have the oil price. Let me check what it looks like. There we go. This is the oil price that I have using the Quandile API. You see? Let's see what pattern, what kind of path the oil price follows during our period. Our period starts at 2010 and ends at 2020. So PLT plots oil, PLT title, crude oil price, PLT X label is dollar. It's in terms of USD. PLT, sorry, it's Y label, not X label. PLT.X label is, right? PLT show. There we go. So there is a big drop in the mid 2014, and then there is no recovery. So crude oil price drops around mid 2014 and fluctuates around 60 USD for the 5 years. Okay, so the last API that I would like to talk about is the World Bank data. World Bank data includes numerous data sets. So one of them, serve your purpose in your research, I guess. This is really useful and comprehensive database. So again, to start with, we need to install the package first, install the library first. PIP install World Bank data. Okay, do you have any problem? Sure. Okay, we are all good, I guess. All right. So once you install this, we are going to import the library. By the way, if you cannot use PIP, if you run this and you get an error, it means that your Python version is not suitable, is not updated for this package, for this API. You need to upgrade your version. Okay. Import bank data as VB. Okay, let me run this. If I type vb.get sources, I'm able to reach these sources inside the World Bank data. Okay, here you see. All what you see here are the databases. These are separate databases: Doing Business Index, World Development Indicators, Worldwide Governance Indicators, International Debt Statistics, and so on. These are different data sets. These are not data. These are, databases, let me say. Okay. I need to pick one of them to move forward because I'm looking for specific data inside one of these databases. Okay. So to do that, we use VB search indicators. Source to, what does it mean? So I left this as blank, but type source is equal to 2, which means that I will go to here and use this database. Okay, word development indicators. So source 2 means the ID. If I pick 2, which means that I'm trying to access the word development indicators. If I define source as 1, then I would like to extract data from the doing business database. Okay, let's access to word development indicators. This is the data sets you have inside the word development indicator database. So it's like agricultural machinery, tractors, fertilizer consumptions. There are tons of different data sets, like nearly 1,500 rows. You see, all rows represents separate variable, separate data. Okay, so it's really hard to specify your data simply by looking at it. So that's why we use keywords to reach our specific data. VB.search indicators. Do that, you are allowed to reach your data. So employment is my keyword. You can use your own keyword, like gross. Maybe you want to reach the gross domestic product, or inflation, or education, whatever it is. But I will prefer using unemployment. Okay, do you have any question? No, okay. Great. Let me continue. So I will run this and wait for the results. It may take some time, it's because it's a huge database, but it doesn't take too much time. I don't think so, at least. Here we go. So when I narrow down my search by typing unemployment, this is the keyword that I'm looking for. So what I have here is the unemployment, the data related to unemployment, like this: unemployment male, of the percentage of male labor force, or unemployment total, percentage of total labor force. Okay, so in order to use this data set, we need to copy and paste the ID again. So for instance, if you want to use this data set, if you want to work with total unemployment, you need to copy and paste it. But before doing that, you need to know one more stuff, which is this data includes every single countries in the world. So that's why I need to narrow down my research in terms of countries. Okay, so for instance, same thing actually, but I need to do that. Otherwise, I get the data for every single countries in the world. So vb.search underscore countries, if I type this, United, I will have the countries with the United word in it. Okay, United Arab Emirates, United Kingdom, United States. Because why we need this? Because I'm going to use this ID. That's why I don't know by heart. I didn't memorize it. So that's why I need to use the keyword and use the ID here to call my country of interest, okay? All right, for instance, I'm going to use USA. What I need to do is to define my variable as unemployment, vb.get series. I'm ready to move forward. That's why I start, defining my code. Let's say I'm going to use this unemployment total for the sake of this analysis. And the country, my country is USA, let's say. And the date, I need to specify the date. It's an annual data, by the way. You have no options. This is just an annual data. Okay. ID or value, I choose ID to narrow down my research. I need to specify it inside the code. Okay. Then simplify index. If you simplify index, if you don't type the simplify index, you still have the results, you still have the data. But if you do that, you have nice looking data, let me say. Okay. So let me copy and paste it to observe what I have. Okay, here we go. This is the unemployment rate, total unemployment rate. Let me check it once again. Total unemployment rate for US for the period of 2010-2020. So there's a huge, drop in unemployment. It's kind of nice for USA. The unemployment rate goes down remarkably. That's a big achievement. So if you want to extend your search, you can do that. You want to use more than one country, feel free to do that. I would like to add Turkey here. Tur is the abbreviation of it. If you don't know it, you just type it. Just type the name, Turkey, let's say. If you do that, here you see Tur. Tur is the one you need to use in your research. So let's run this and see what it looks like. All right. So you have the unemployment rate for Turkey and unemployment rate for USA. Okay. So it looks fine. All right. This is all about the APIs that you can use for financial, economic, and social indicators. If you are planning to run a research or run an analysis in these fields, this data, these APIs helps you a lot along the way. Okay. So the next part is about the regression analysis, which is the first and one of the foremost analysis in machine learning. And before, starting regression analysis, if you have any question, I will be more than happy to answer it. If you don't, I would like to give a 5 minutes break. Do you have any question? Sandeep, it's good to see you here, by the way. A question from Dave. Is there any better way than a Google search to find an API for some data source? Find an API for data source, you mean, or are you talking about tickers, Dave? Because you cannot easily find the API simply by Googling them. Why do companies like Yahoo provide use of these APIs for free? The dataset in Yahoo Finance is for free too. But if you are looking for some intraday data or option prices, something like that, if you are looking for something specific, this is not for free, Dave. We have a database called WRDC. This is a database for the Wharton School, University of Pennsylvania. This data includes different, financial data sources, which is a huge database, but it charges a lot. So it costs a lot. So that's why if you have a free databases, this means that this, data are, not very specific or not very, or, maybe it is open to public for, for the sake of, researchers. I don't know. For instance, for the World Bank data set, we have many variables. I use this database a lot. This is one of the aim of the World Bank, provide data to conduct research. So this is one of them. As for the Yahoo Finance, we have some, not for free data in Yahoo Finance, but stock price is not one of them. Okay. And there is no short way to find the tickers. Maybe if you Google it, you will find the list, Excel list, a list in an Excel of the tickers listed in S&P 500 or other indexes. You can find a whole list of tickers for the USA only, not for every single countries. Okay. It seems like I need to find an API. You need to find an API. So in order to have the API, in order to use the API in Python, we need a source code, okay? We don't have the source code for every single database in finance or in economics. So as long as we have the source code, we can use APIs. But for instance, there are tons of different, database such as Google or investing. Investing is, by the way, investing prepared his API, by the way. It just released a couple of months ago. But as I said, we don't have the API for every single database in the field, okay? So I have no answer to this question. Let's talk about regression analysis. As I said, this is one of the first analysis in machine learning environment. It's an old analysis. It dates back like 1950s, maybe it's like 50 or 60 years old. Gene has a question, I guess. Let me see. Okay, Gene, do you have any question? Can you hear me? Oh, you are mute. If you want to talk, you can unmute yourself. There's a misunderstanding, I guess. Okay. Okay, anyway, let me continue. So we are going to discuss more in Magnimind Academy, the regression analysis and other topics in machine learning. We dive deep in our boot camps. But here I would like to talk about how and why we use regression analysis. So regression analysis is a linear model, but it doesn't mean that we just use the linear variables. Linearity in regression analysis means the linearity in the coefficients. Okay, we are not talking about the variables. We are talking about the coefficient when we say linearity. Okay, let me type a regression, an equation for you, and it makes more sense to you. Y is my dependent variable, okay? And beta 0 plus beta 1 times x1, let's say, plus beta 2 times x2 plus epsilon. This is my equation. So y is my dependent variable. Beta 0 is my intercept term or constant term. Beta 1 and beta 2 are my slope terms. X1 and X2 are my inputs or variables or future, however you put it. And epsilon is the error term. So if I take this epsilon out of the equation, it turns out to be a deterministic equation. Okay, there is no randomness in it. So it's just you need a mathematic to solve this equation. But if we are applying statistics, we need a randomness. We need a probability. That's epsilon puts into this equation. So that's why epsilon makes this deterministic equation into probabilistic one. So it makes mathematics into turn mathematics into statistics. Okay. So here the ultimate aim of the regression analysis is to estimate these coefficients, beta 0, beta 1, and beta 2. Okay. The linear regression, the name of linear regression comes from the linearity of these coefficients, beta 0, beta 1, and beta 2. So it's a bit confusing because when we say linear regression, people thinks that it's a linearity in the variables x1 and x2, but it's not. You can take the logarithm, you can take the square root of them, or you can take the exponential of them. Feel free to do that. You can play with the functional form of the equation. But the thing is, the estimated coefficients, the betas, should be the linear. Okay. All right. So for the sake of this regression analysis, we are going to use insurance data. You remember, I sent it to you. Someone is, who wants to ask a question, I guess. Let me see. Okay, I cannot, allow you to talk, I guess. I cannot unmute you. Sorry about that. Could you please type your question in the Q&A? I will try to answer it. Okay. All right. So Rupesh, hi. Can you upload the previous 4 classes? It's already uploaded, Rupesh. It's already uploaded. Okay, Dave asked another question about the API. Let me answer it and then move. I will go back to the regression analysis. What I was trying to ask is how do you find an API for a particular data source? I vaguely remember there was a website related for this. In your particular case, how did you learn there was a Okay, I got it there. So yeah, I come across and see in some researches and this kind of stuff. So there is no automatic way to detect the APIs. I either learn it from my own research or I just come across with them. Okay. All right, let's go back to regression analysis. I'm going to use scikit-learn. Scikit-learn is the library that we apply very often in data science. sklearn.linear_model import linear regression. So there are more than one ways. There are more than one way to run the linear regression in Python, but I'm going to prefer using sklearn for the sake of this practice. Okay. We can run stat models to run the linear regression. We can do that too. It's all up to you. All right, I will run this and I will import my data pd.read csv insurance.csv. the name of my variable may be insurance df. Okay. Oh, the data is not found here. I have it somewhere here, but it's not found. Insurance CSV, it's here. Let me check. What's the problem? PD underscore CSV insurance dot CSV insurance. So it should work. Is there a typo here? Insurance CSV. It's here. Maybe my notebook is not here. Let me create another notebook. Maybe it's not in here. Let me copy this and paste it here, and then try PD read CSV. I don't want to play with the directory. This is shorter way. I need to check if it is here. Oh, I'm sorry. Yes. Import pandas PD, and then this one. Okay. Then it's about the directory. Okay. Let me continue from here. All right. Insurance DF. Insurance DF is my data set. Let's see what it looks like. So it includes age, sex, BMI, children's, smoker, region, and charges, which means that insurance charges is somewhat related with the age, sex, BAS and body mass index, children, smoker, and region. Okay. So I'm going to build an equation, something like this. Let me copy and paste it here. Okay. Something like this. And the dependent variable will be charges, insurance charges. I will try to explore the relationship between insurance charges and these variables. Okay. These variables will be my x1, x2, x3, x4, and etc. Or I can drop some of them if I think that some of the variable is unrelated. So I can drop them. Okay. For instance, age is not related. So I drop age and use the rest of the variables. Okay. So great. What I'm going to do is to observe the distribution of the charges. So before doing the analysis, the first thing is to get familiar with the data set, with the variables you have in the data set. Okay. Insurance df dot charges. Here we go. Oh, I need to import the packages from here. Import matplotlib.pl plots splt. All right. Changing the notebook comes with a cost. So here you see. So what I see is that insurance charges gathers around 0 and 10,000. I have numerous observations here, but as I move to the right, and insurance charges around 60,000, I have few observation around here, around 60,000. So the observation is widely skewed to the left, to the right. So it's positively skewed because the outliers gathers around on the right hand side, gathers towards the right hand side. So it's called right skewed. Okay. So, but it's quite obvious that it's not normally distributed. We talked about the normal distribution in our previous session. So it's not normal distributed. So, okay, let's define a variable of interest. Insurance df is my data. I define a new variable is male. With this variable, I'm trying to make use of the sex variable in here because this is an object variable. It includes females and males. I cannot use it this way because it is text. I need to turn it into a numerical variable, which is called discrete variable. So there is a convenient tool in Python to do that, which is called getDummies. So I will turn this sex variable into a dummy variable like this: insurance underscore df dot sex. Okay, drop first. Drop first means that it's rather technical, but I'd like to talk about it a little bit. If I use male and female at the same time in my analysis, it leads to a dummy trap. Please go and read dummy trap right after the session. If you are going to use a dummy variable, you need to use either one of them. You cannot use male and female. You just either use female or male, because one of them is represented in the constant term, which is this one, okay? The way we interpret the dummy variable is a bit different from the normal variables, okay? So here is the smoker. Let me see. Smoker is again an object variable. It's text, yes and no. I turn it into a numerical variable here, okay? So if I check my new data set, insurance DF, this is what I have: male or smoker. Is this male? No, it's female. You see? Is it male? Yes, it's a male. And then is smoker? No. Oh, sorry. The 0 is representing yes, 1 representing no. Okay. All right. So what's left is to observe the variable more. Let me do that. I would like to see the distribution of the is male and is smoker variable. Let me do that. So I will use bar plot insurance df dot group by. If I group by the is male variable here, it's easy to see the changes of charges, how the charges mean per sexes. Okay, this is what I'm looking for. So the x-axis will be the indexes and y-axis will be the data. So this is y-axis, insurance df group by is male charges mean, but my x-axis is the indexes. Whatever index I have, I will have on my x-axis. Okay, so let me define the color to prevent any confusion, which is green and gray. Right. Let me see if everything is fine. Here we go. So let me assign a name to the X and Y label. Otherwise, it creates some confusion. Is male is the x-axis. Y-axis is the average cost, because I group by and analyze it by charges, insurance charges. That's why it is average cost. Here we go. So this is what it looks like. So if you are male, or female, the average cost changes a bit, but not that much. So the gender does not have a huge impact on the insurance charges. This is what this graph tells us. There is a, there's a difference, but it's not that, large. It's not that big. So let's do the same thing with the is smoker. I will change the variable only, is smoker instead of is male. Okay. So is smoker average cost. Here we go. So if I'm using the is smoker instead of is male, so hold on a second, these are the same graph. There is something wrong, I guess. Let me check. Insurance DF is smoker charges me. I have to check if there is any difference because this looks same to me. That's why. Okay, maybe I did something. Oh, okay, here I did something wrong. This is not sax, this is a smoker. Sorry about that. I need to fix this. Okay, now it works. Now 1 is yes, 0 is no. Okay, it's not a big deal. You need to know which one is which one. 0 maybe yes, 1 maybe no. It doesn't a big deal, but you need to know which one represents which one. Okay, so let me rerun this. Here we go. There is a huge difference because is smoker. If you are a smoker, your insurance charges should be much higher than the non-smoker one. That makes really sense. Okay, so comparing the gender, being a smoker means a lot in terms of insurance charges. All right, so this is what we understand, from the variables that we are about to use. So let's, build our regression equation using these variables. Charges eta 0 plus eta 1, and the variable is smoker plus eta 2 times is male plus epsilon. Here we go. So let me fix this. Is smoker and let me do that. I take the curly bracket here and here and here and here. Okay, still it's not working. Let's do this. Here we go. So my dependent variable is charges, and I am trying to explore the relationship between charges and is smoker and is male. Sorry, and is smoker and is male. Okay, so in order to do that, I am running a linear regression. So my y variable is insurance F charges. Okay. My x variable is insurance F double brackets, because I'm going to use two different variables, is male, is smoker. All right. What else? Let me run this. What I need to do is to configure my linear regression, linear model. It's coming from linear model package, linear regression. You can, play with the hyperparameter inside these parentheses, but I prefer to leave it blank for the sake of easiness for this analysis. I assign a name to this variable. From this point on, I'm going to use LRM instead of this. Okay. So this abbreviation is representing my linear regression now, what I need to do is to fit my variable. First is independent variables. These are my independent variables, x, and then dependent variable. The order matters. Please pay attention here. The order matters. Otherwise, your regression analysis doesn't tell you anything. It's wrongly defined. Okay. So if I run this, what's the problem? Oh, I didn't run the linear model. What's wrong with the linear model? I can easily run the linear regression too. So let me drop it because I run the linear regression. Okay, because here I run the linear regression. That's why I don't need the linear model because I imported from here. Okay, so it's running. It works well. How about the results? Let me print the results. Print coefficient first. Coefficients. And then lrm dot coef. This is my first this is my coefficients, the about the beta 1 and beta 2. How about the intercept term? Intercept term, which is intercept underscore. This is this. So beta 0 is this big, and this is beta 1 and this is beta 2. So how would you interpret this? This coefficient tells us that if you're a smoker, sorry, if you're a male, the smoker is here, okay? Because I put it here. Maybe this is confusing. I can change the order because I define smoker in the second part, attached to the beta 1 below. That's why this is better. Same order. Okay. So if you're a smoker, your insurance charges is really high because the equation, you can put this variable instead of beta 2. So there's a positive and high correlation between the charges, insurance charges, and the smoker. But it's not the case for male. If you are a male, your insurance charges may drop, but it's not a perfect way to interpret the result because there is a term statistical significance in linear regression. We need to make sure that this estimated coefficients are statistically significant or not. This is another concept. Let me define it. In order to do that, I am going to use another package because there's no way to do that in linear regression. That's why I always prefer to run stats model to use stats model to run the linear regression. So I suggest you to do that because stats models provides us a summary table, not just the coefficients and intercept term. It provides a summary table so that it's really easy to interpret the result. But the trick in stats model is this: it's not, you need to define your constant variable. The constant variable is this. You need to define your constant variable before moving forward. Okay, this is a trick in stats model. Other than that, it's really easy. Results SM is my package here. sm.ols. OLS means ordinary least square, which is the same thing with linear regression. Okay. And the order changes. It's y and x now. Y and x dot fit. Okay. And results dot summary. If I do that, I have the summary results like this. Looks really nice. So it's for sure that I have the same coefficients. Let's check it. Minus 65 point blah blah and 2.36 e to the 4. That's why it's the same thing. So the coefficients are the same because the optimization procedure behind the stats model and linear regression package are the same, but the way they present the result is different. So that's the issue here. So what I would like to talk about is the t-statistics and the p-value. Okay. In order to understand the relationship between the variables, between the independent variable and the dependent variable, we need to interpret either t-table, t-statistics, or the p-value. I always prefer using p-value because if you're interpreting the t-value, you need to know the t-critical values. If you know the statistics, you know this. Every statistical textbook, if you take any statistical textbook and look for the appendix, you will see a t-score table at the end of it. So every statistical book has a t-score table. Depending on the confidence level and the degrees of freedom, you have a constant critical score. Depending on the critical score, you interpret the test result. I know it's a bit, discouraging. That's why I need to talk more about the p-values. So depending on the confidence level, we define the we can interpret the p-value. The conventional confidence levels are 90%, 95%, and 99%. Okay. So if you have 0.1 p-value, less than 0.1 p-value, it means that your estimated coefficients are statistically significant, which in turn means that you can interpret your result. Okay. If your p-value is higher than 0.1, then this implies that the variable is not statistically significant. The estimated coefficient is not statistically significant, which means that even if you have the result here like this, you cannot interpret this because you accept the null hypothesis, which assumes that beta is equal to 0. Beta is not that one. Beta is equal to 0. Because in this test, we have an hypothesis. Let me type the hypothesis for you. H0 is beta, say beta is equal to 0, whatever beta is it. Let me type beta I, okay? Or, sorry, this is the null hypothesis. We talked about the hypothesis testing before in our previous session. HA is the alternative hypothesis, which assumes that is not equal to 0. Okay. So, sorry, it's just beta I. Beta I is not equal to 0. So, if the p-value is greater than 0.1, then we accept the null hypothesis, which means that this estimated coefficient is 0, is not this one. So it's not true to say that being male has a negative impact on the insurance charges, okay? But it really makes sense to say that being smoker has a huge impact on the insurance charges because p-value is less than 0.1. Okay, so do you have any question? It's a bit confusing, I know that. Okay, Farida, I'm clueless. It looks like a bunch of exponential. Oh, you are talking about this one, right? So this exponential is nothing but the numerical stuff, okay? So let me show it to you. So here you have the open version of it, full version of it. Somehow, some way, some of the algorithms produce this kind of representations. but please do not intimidate with this. It basically says that you need 4 more decimals, 4 more digits here. Okay, move to the right. That's all. Dave asked a question. When you called fit, X was first. This one, yes. Yeah, that's right. Order matters. That's right. It's a bit confusing. I know that, but if you are using stat models, Dave, you need to put the dependent variable first and then independent variable. If you are using what's that? Linear regression, you independent variable first and then dependent variable. I sometimes forget which one is which one. I'm just Google it and figure it out. That's how it works. Okay. So the linear regression is a parametric method, parametric model, which means that we have some assumptions. We have some assumption about the distribution. We have some assumptions about the model. Okay. The strength of the linear regression is that we have closed form solution. We know the formula for the betas, for the estimated coefficients. This is the strength of the linear regression. But the weakness of the linear regression is that this is not a flexible model. Okay. Once you estimate the coefficients, it doesn't varies depending on the variable, depending on the values you have. So this is not a very strong model in machine learning. Actually, if you have a parametric model with a tons of different assumptions, this implies that your model is not flexible. In machine learning, flexible models produce more accurate results than the inflexible models. Okay. So for instance, random forest boosting algorithm, neural network, these are flexible models. So that's why they produce low biases compared to the parametric or inflexible models, okay, such as linear regression. All right, so what are the assumptions that we need to satisfy in linear regression? I'm not going to go into detail. I'm just, talk a little bit about the assumptions, because if these assumptions do not hold, it makes no sense to run the linear regression. Okay. First is linearity in coefficients. As I said at the beginning of this session, when we say linearity, we refer the linearity in coefficient, not in the variables. Okay. Constant variance. So we need to have constant variance between the predicted values and residual. Residual is the error term. Error term is called residuals too. So which means that when we change the values, the variance should not, change a lot. So we need to have constant variance in the prediction. Okay, this is one of the other assumption in the linear regression. This is called homoscedasticity, by the way. Homoscedasticity. Okay, heteroscedasticity means changing variance. All right, low collinearity. If you have high collinearity, which is called multicollinearity, this is something that you need to handle. Okay, if you have a correlation greater than 0.80 between the two independent variables, you need to drop either one of them to move forward with the linear regression. Okay. Uncorrelated error terms. Error terms should be uncorrelated to each other. This term should be uncorrelated to each other. We have error terms for every single line here. Okay. And these error terms should be uncorrelated to each other. Otherwise, it produces some biases. Okay. independent variables, should not be correlated with error term, which means that in order to satisfy these equations, we need to include as many variables as possible because we are trying to explain the changes in charges, right? If we miss a variable, epsilon includes this to satisfy this equation, right? So, for instance, you drop this variable. Let me do that. You don't use this variable. I need the plus sign here. So you drop the ismail variable, which is assume that which is highly related to the charges, insurance charges, but you miss this variable, and epsilon includes this to satisfy this equation. So this variable in this case is correlated with the error terms, which we shouldn't have. Okay, if we have something like this, we need to deal with this. We need to include more variable, or we need to visit our functional model, something like that. Okay, but we need to do something to get rid of this problem. Okay, what else we got? The error term should be 0 on average. Okay, if we don't have a 0 error term, it leads to bias in our model. So the average of the error term is equal to 0. Okay. I know that it's really hard to understand the linear regression in 1 hour. So I'm going to refer you some book. At the end of the session, we are going to send an email to you along with the video that we are recording right now. So yeah, I hope it helps you to understand the linear regression. And if you are looking for more information about the data science and data science application with Python and in general machine learning applications, we have a bootcamp in Magnemind Academy. I strongly suggest you to apply and attend the bootcamp so that you can improve your knowledge in machine learning. So our 10-hour Python course ends here. It's really a pleasure to meet with you once a week. Wait for our next workshops. We are going to host workshops in the days ahead. So I hope we meet you there too. So thank you for attending. By the way, if you have any questions, I don't see any question in the Q&A. That's why if you have any question, feel free. If you don't have any questions, I'm done here. A question from Angela: is smoker field you should use smoker? That's right. That's right, Angela. That's right. Emilio has a, oh, okay. Let me check the references, Emilio. Machine learning, you know what? I have no idea about this book. Reinforcement learning, yeah, Sutton and Bartow. This book is, the literature maker in reinforcement learning. It's a really good one. Deep learning, this book is a bit hard for the beginner. So I would suggest you to, study the deep learning with the book of Francois Cholet, who is the creator of Keras. So Frances Chole's book is a bit, suitable for beginners. If you are a beginner, if you want to dive deep, really dive deep into deep learning, so this book is for you. Deep learning for, dive into deep learning from Zhang. It's a good one, really good one, but it's not easy to follow for the beginner, for a beginner. All right, Angela, I sometimes teach in the bootcamp too, but we have different, mentors and instructors in the bootcamp. I'm just one of them. All right, let's see either in the bootcamp or in the workshop. Let's, close the session for today. Goodbye. Take care of yourself.